Welcome everyone to our presentation on our robotic delivery system for UNC Charlotte's campus. My name is Brandon Bryant. I'm the project lead, and I'm going to be taking you through all of our hard work over the past 2 semesters for Senior Design 1 and 2. So our objective was to develop a robotic delivery system that is autonomous. It was split up into 2 teams, an algorithm team, which worked to create the algorithm to control the robot given a path of GPS coordinates, and the map team, which worked to create a pathfinding algorithm to navigate between 2 points. In other words, finding the shortest distance between those points. So our required specifications were a foundation based on Dijkstra's or A-star. It had to work with the TurtleBots that existed in the core lab that we were using, and it should be existing accessibility ramp data on campus that is used in the algorithm. So some reasons for developing something that's so similar to Google Maps is, one, the node density provided by Google Maps is not sufficient to tell a robot where to go. And 2, robots cannot traverse stairs. They need ramp data. This is what separates us from Google Maps.
Our technical approach was to use a modified Dijkstra's as our pathfinding algorithm. We created a node abstraction to reduce our runtime, which required us to define intersections and delivery points. We then gathered GPS data from the OSRM API. Afterwards, we developed a visualization which used a combination of both a high-resolution map and a 3D environment. Our progress so far includes a fully implemented Dijkstra's algorithm which can also use A-star. We have published a paper to the IEEE Southeast Con 2022. We have created a database of all the GPS road, ramp, and building data, alongside a 3D gazebo world file of the campus. Finally, we have created functions to modify the generated path for our TurtleBots.
Our team has also created an application called Turtle Maps that is able to run the algorithm on computer and mobile devices. It utilizes a library called Kivy that helps us implement a map widget from OSM to create interactive, customizable maps. The main novelty of our project is that our algorithm is capable to display ramp-accessible paths not found in other navigation applications such as Google Maps. This is very important for robots such as TurtleBots that's going to be used for delivering medical supplies to students, that can also be used for navigation in zoos and parks, and can also be equipped with cameras and used for security or surveillance purposes.
So for future semesters, a similar framework can be used for the inside as opposed to the outside. Gazebo simulation can be used for other researches on campus, and also we can use the graphical user interface to display battery levels and travel time for the TurtleBots.